Okay, so we are actually going to start the real trig part of this unit. We do start off with the unit circle. This is where trigonometry actually comes from. So I do need you guys to recall right triangle trigonometry from geometry from last year. So you probably learned what sine, cosine, and tangent are equal to, how to remember these ratios as SOHCAHTOA. So it's SOHCAHTOA. So the S in so is for sine, the C is for cosine, and the T is for tangent. All right, so that means sine is the O and the H is opposite over the hypotenuse. So sine is opposite over the hypotenuse. Cosine, which you have the A and the H here, that's adjacent over hypotenuse. And TOA, which is the O and the A, that's opposite over adjacent. Okay, so let's take a look at these triangles. And I have the right triangle. I have this angle here is 23. We have a side of x and 7. So if you want to solve for x, the first thing you did was you labeled a triangle. So you always start with the hypotenuse because the hypotenuse is always opposite the right angle. So that's H. Put an H there. This x is next to the 23, so that would be the adjacent. Adjacent means next to. This side that's across from your angle, this side here, is opposite. Now, which side is not even involved, that has nothing to do with the problem, is the O side, the opposite side, because there's nothing there, so cross it off. So which function, sine, cosine, and tangent, uses adjacent and hypotenuse, and that would be the cosine. So it's cosine. The x, this number that goes there, is the angle. In this case, it's 23, is equal to the adjacent, which is x, over the hypotenuse, which is 7. So you want to solve for x. So what you would do is you would put this over 1 and cross multiply. So you get x is equal to 7 cosine 23. You could plug that into your calculator. Just plug it in just like that, 7 cosine 23, and you get 6.4. That's to the nearest tenth. I rounded it. If you did not get 6.4, you got something different. Just make sure that your calculator mode is in degrees. So press mode on your calculator if you did not get 6.4. And make sure you're in degrees, not radians. You do not want to be in radians for this. So you want to be in degrees. Okay, and then you could retry and you should get 6.4. All right, so let's take a look at the next one. So I always start with the hypotenuse first. There's the hypotenuse. Across from the angle, 41, that's opposite. And next to the angle, that's the adjacent. So the hypotenuse is not involved because there's nothing there. So which one, sine, cosine, and tangent, uses opposite and the adjacent? That is tangent. So it's going to be tan 41. That's the angle that goes with the function. And that's opposite over the adjacent. So that's x over 12.5. I'm going to put tan 41 over 1 and cross multiply. So I get x equals 12.5 tan 41. Okay, so just plug that in your calculator at one time. To the nearest tenth would be 10.9. Okay, and the last one over here on the side, we're going to label hypotenuse. Across from the angle would be opposite, and this side here next to the angle, which there's nothing there, is the adjacent side. So which one uses opposite and hypotenuse? That would be sine. So I have sine. What goes with the function is x equals opposite over the hypotenuse, which is 21. Now, when you're looking for an angle, this is an angle measure I'm looking for, you use the inverse key on the calculator. That's that sine to the negative 1 power. So you do second sine, and then you type in 10 divided by 21. And this is, you can round this to the nearest degree, you get 28 degrees. Okay, so that's review from last year. You should know that stuff. Okay, so now let's talk about the unit circle. So just really quickly on the side over here, in trigonometry, they use Greek letters a lot instead of like X and Y. We still use X and Y for our unknowns, but you're going to start seeing some Greek letters now. So the most common one to see is theta, this one here. This is phi, and this would be beta. I'll print a list up of Greek letters so that if you come across a Greek letter and you want to know exactly what its name is, you can look it up. All right, so the unit circle. So the unit circle is, you have a center at 0, 0, and your radius is 1, meaning 1 unit. So that means we're going to go to the right 1 unit. So if I go to the right 1 unit, this point right here would be 1, 0. I'm going to go up 1 unit. So this point here would be 0, 1. I would go to the left 1 unit. This point here would be -1, 0. And I would go down 1 unit. And this point here would be 0, -1. All right, so you want to draw your circle the best that you can. I'm going to try to draw mine the best that I can too. So just try to draw it the best that you can. Okay, so not too bad, considering I'm doing this on the iPad. All right, so now let's say I have this point here on the unit circle. So I'm going to call this point P. I'm going to call this point P. And what I know about this point is that it's some xy value. I don't know what that xy value is, but I know it's some point. XY. And I do know this, that I can take from the center and draw in my radius. And I know that the length of this radius is 1, because remember, we went up, down, left, right, 1. So this is a length of 1. All right, so now to figure out what that point is, what we want to do is, from the point P, is drop the altitude down. So we're going to drop the altitude down. Oh, and one other thing is that, remember yesterday we did angles in standard position. This angle here is an angle in standard position, and I'm going to call that angle theta. And now what I'm going to do is I'm going to drop the altitude down. Okay, so I drop the altitude down. And I make this right triangle here. So I drop the altitude down, make this right triangle. So I have a right triangle, and I have this angle here that's in standard position, and that's angle theta. That's terminating in quadrant 1 with P being a point on the unit circle. All right, so this is something that I do know, that when I graph a point, like when I graph point P, this value for x is the distance from here to there, right? Because when you graph a point, you go over x. So whatever number this is, that's what number this is. This is the length of this side. So if this is x, I know this length here is x. And when you graph a point, you go over right for your x value, and then you're going to go up your y value, whatever your y value is. Your y value up is whatever this y value here is for your point. So I know that value there is y. All right, so now using our right triangle trigonometry that we just talked about above, all right, I know sine, remember sine is opposite over the hypotenuse. So I want sine of theta. So which side is opposite theta? Opposite theta is y. Over the hypotenuse, which is 1. So that means my sine theta is equal to y over 1. So therefore, sine is equal to my y value. All right, now let's do cosine. Cosine is adjacent over hypotenuse. So which side is adjacent to x, to theta, sorry, is x. So that would be x over the hypotenuse, which is 1. So therefore, cosine is equal to x. All right, so now let's talk about tangent. I am going to have to move this over, so give me a second. Okay, so remember, tangent is opposite over the adjacent. So opposite would be your y value over the adjacent, which is your x value. Okay, so therefore I can substitute into for x and y what x and y are equal to. Y, remember over here on the right side, y is equal to sine, and x is equal to cosine. So therefore tangent is equal to sine theta over cosine theta. So this here is an identity. You have to know that identity. You have to know that tangent is equal to sine over cosine. All right, so now back to this. My x is equal to cosine. My sine is equal to my y value. So therefore, this point P, which is xy, x is cosine theta, and y is sine theta. So down here at the bottom of your paper, just fill that in. That your point P is x is cosine theta, and your y is sine theta. Okay, so you have to know that. You have to know that a point is represented as cosine and sine, and that tangent is sine over cosine. Okay, so let's flip the paper over. Okay, so let's take a look at the first problem. It says here, find point P, which is xy, located on the unit circle to the nearest tenth. Okay, so I know, look at where my point is. It's over here in the third quadrant. And this is what I know, that my point, P, is cosine theta, comma, sine theta. And your theta is whatever your angle is that's terminating in quadrant 2. So your theta is this angle. And this angle is 143 degrees. This is theta, 143. So I can then change my theta here to 143 degrees. So cosine, 143 degrees. Just plug that in your calculator. I want to the nearest tenth. So you get negative 0.8. And then you could do sine theta, which is sine 143. Plug it into your calculator to the nearest tenth is 0.6. So therefore, this point P is negative 0.8, because that's your x value, is cosine, and your y value, which is sine, is 0.6. And that makes sense, because you're in quadrant 2, and your x value is negative, and your y value is positive in quadrant 2. Okay, so let's take a look at number 2. It says find sine, cosine, and tangent if P is on the unit circle. Okay, so remember, point P on the unit circle is cosine theta, comma, sine theta. And remember, your point is x, y. So therefore, sine theta is your y value. What is my y value? Square root of 3 over 4. That's what sine theta is equal to. Cosine theta is your x value. So my x, right, cosine is your x value. My x value is negative 3 over 4. Now tan theta, tangent, remember, is sine over cosine. So this is the square root of 3 over 4. Now, I'm going to write this as a division problem, right, because it's really this, over negative 3 over 4. So this is really, then, this is, let's move this up, the square root of 3 over 4 divided by, that's the bar, negative 3 over 4. When we divide fractions, you do same change flip, so it's the square root of 3 over 4 times negative 4 over 3. You can reduce 4 and 4 to 1 and 1, so it's negative the square root of 3 over 3. Okay, so that's it, and we'll practice some more in class tomorrow. All right, have a good night. Okay, so let's talk about the reciprocal trig functions. So reciprocal, first of all, means to flip. So flip the fraction. So if I have what is the reciprocal of sine theta, so when I flip it, the reciprocal of sine theta is 1 over sine theta. But we don't normally like to write reciprocals like that, so we have a new trig function that's called cosecant theta. So that's cosecant theta. The reciprocal of cosine would be 1 over cosine theta. And we would call that secant theta. And the reciprocal of tan theta. Now remember, tan theta is equal to sine over cosine theta. So the reciprocal of tangent would be 1 over tan theta, which we call cotangent theta. So that would mean that cotangent theta would be the reciprocal of this guy here too, which would be cosine theta over sine theta. So you have to know these are all identities. So you have to know all these identities. Okay, so for instance, let's say I give you a point. Let's say I give you a point on the unit circle. And the point on the unit circle is 1/2 comma the square root of 3 over 2. So sine theta, remember sine is your y value, so that's the square root of 3 over 2. Cosine theta is your x value, remember that's 1/2. Now tan theta, remember, is sine over cosine, so that's the square root of 3 over 2 over 1/2. So this is the square root of 3 over 2 times 2 over 1. I just did same change flip. That's how you divide fractions. So this comes out to be the square root of 3. So now if I want secant theta, secant is the reciprocal of cosine. So that would be equal to 2. Because I took 1/2 and I flipped it. Cosecant theta is the reciprocal of sine. So I would flip it and I get 2 over radical 3. Now in pre-calculus you do not have to rationalize the denominator like we did last year. And cotangent theta is the reciprocal of tan theta, and tan theta is radical 3, so I flip it and I get 1 over the square root of 3. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.